So in this video, before we move to the case 3, we have in converting fractions to decimals. There are actually some types of decimals we have to take note of. So there's the terminating decimals. There are decimals like 1.25, 0.6. So they are terminating. So they have an end. You can see 1.25, 0.6, that's the end. They have an end. And they are always rational numbers. They're always rational numbers. For example, 1.25 is gotten from 125 over 100. So it's a rational number. Also, 0.6 is also gotten from 6 over 10. So they are always rational numbers. For recurring decimals are non-terminating. Exactly. So we have endless decimals that are what? That are non-recurring. So we have endless or non-terminating decimals that are also what? Non-recurring. And also have recurring decimals that are what? That are also endless. Or let's just say all recurring decimals are they're endless. All recurring decimals are they're always endless. So once you hear recurring decimals, it's always endless. Decimals like 0.5555. Decimals like the ones you get for example from 3 over 7. 3 over 7 gives 0.428571. 428571. You can see this 428571 is repeating itself. That's why it's called the recurring decimal. Numbers like 1 over 3, it gives what? 0.33333. So it's endless. So they are called recurring decimals. And I said all recurring decimals are actually endless. They're not terminating. So you don't have to say recurring terminating decimals because all recurring decimals are non-terminating. Now, we now have endless decimals or non-terminating decimals that are what? They are non-recurring. So we added that non-recurring to distinguish it from recurring decimals. Because recurring decimals are also endless. So also these non-recurring decimals are also what? Endless. So we say non-terminating recurring decimals and non-terminating non-recurring decimals. So the non-terminating recurring decimals are the ones we've seen here. So why the non-terminating non-recurring decimals are decimals that do not they are endless. At the same time, they do not recur. They do not repeat themselves. So examples are pi. Pi is also exponential. Exactly. So value of pi 3.142 is endless. Also 2.718 is endless. And these numbers do not recur in a regular pattern. So they are not random numbers after this. So we have terminating decimals. Those are the ones we have 0.6, 1.25, they have an end. We have recurring decimals, and they are always non-terminating, they are always endless. For example, 3 over 7, you can see 0.428571. So that same number, 0.428571, repeat itself as regular intervals. We also have 1 over 3, which is what? 0.3333, and it's endless. So it is recurring. You can see those numbers, they occur at regular intervals. But we also have endless or non-terminating, non-recurring decimals. So they're also endless, but they are not non-recurring. Example is pi and also what? E. So E is 2.718, and then we have some other random numbers. So numbers are random. They do not repeat themselves with a regular pattern. Also in pi, 3.142, and then you have random numbers. Now, I want you to take note of is that for terminating decimals and non-terminating recurring decimals, these two, they are formed by rational numbers. They are formed by rational numbers. What are rational numbers? They are numbers that can be expressed in the form A over B. They are what? Numbers that can be expressed in the form A over B. So any number you can express in the form A over B, where A and B are integers. Where A and B are what? Are integers. That number is a what? The number is a rational number. Why these non-terminating or endless non-recurring decimals? They are always a rational numbers. And there are numbers that cannot be expressed in the form a over b. Example is pi, example is exponential. So they give irrational numbers.